Morning students, myself Vijay Shankar from ECE department, Shiprol Engineering College. Today we are going to discuss about the Z transform properties. Already we discussed about the two properties in the Z transform. One is linearity property, another one is a shifting property. Let us see once again the linearity property and the shifting property. The first property is a linearity property. It states that there's a transform of a linear weighted combination of discrete time signals. There's a transform of a linear weighted combination of discrete time signals is equal to similar linear time weighted combination of Z transform of individual discrete time signals. A linear weighted combination of discrete time signals is a combination A1 x1 of n plus A2 x2 of n is equal to the similar linear weighted combination of Z transform of individual discrete time signals, x1 of z and x2 of z, where a1 and a2 are the constants. The Z transform definition x1 of z is equal to the Z transform of x1 of n is equal to sum of n is equal to minus infinite x1 of n z power minus n is the definition of the Z transform. Because of we are taking the signal is x1, we get the x1 of z, and second one is a x2 of n is a signal, get the x2 of z is another function. Now combining the linear weighted combination of discrete time signals a1 x1 of n plus a2 x2 of n combination, substituting the definition of the Z transformation, a1 x1 of n plus a2 x2 of n z power minus n, and that is equal to the sum of n is equal to minus infinite a1 x1 of n z power minus n plus a2 x2 of n z power minus n. Now split the two parts are two terms. Sum of n is equal to minus infinite a1 x1 of n z power minus 1 minus n plus sum of n is equal to minus infinite a2 x2 of n z power minus n. The a1 is a constant, take the outside, sum of n is equal to minus infinite x1 of n z power minus n plus a2 into sum of n is equal to minus infinite x2 of n z power minus n. See, here the definition of the Z transformation with x1 of n as a signal. It is also the definition of the Z transformation with the signal x2 of n. So a1 x1 of z plus a2 x2 of z. That is equal to the similar linear weighted combination of Z transform of individual discrete time signals. Coming to the second property, shifting property is the first property and this one is the second property. Shifting property, the case one, the two-sided Z transform. Two-sided Z transformation. What is the statement of the two-sided Z transformation? The shifting property of Z transform states that the Z transform of a shifted signal, shifted by m units of time, either towards the right side or towards the left side. Towards the right side means you can take x of n plus the plus here, the minus plus m values, because I am taking the positive values towards the right side. If it is towards the left side, n minus of minus m, negative values of m. Okay, it we call it as a delay signal, and it is advanced signal. Advanced signal. The reference is a 0 here. Reference is a 0. The shifting property of Z transform states that the Z transform of a shifted signal shifted by m units of time is obtained by multiplying Z power m to the Z transform of unshifted signal. Let the Z transform of x of n is x of z, then Z transformation of x minus minus into plus is a minus, x of n minus m is equal to Z power minus m is multiplied with the unshifted signal Z transform, and Z transform of x of n plus m, minus into minus, it becomes a plus. So shift it towards the left side. You can multiply the Z power m for the unshifted Z transform signal x of z. Means for positive values of m, you'll get negative powers of z, and negative values of m, positive powers of z is multiplied to the unshifted or the Z transform of unshifted signal. Okay, let you go the proof. X of z is equal to the Z transform of x of n. The sum of n is equal to minus infinite to infinite, x of n z power minus n, and substitute x of n minus m in the signal x of n minus m z power minus n, and let assume n is equal to n minus m is equal to p, and n is equal to p plus m. And the range of n is from minus infinite to infinite. Similarly, the p is range is also minus infinite to infinite. The sum of p is equal to minus infinite to infinite. X of n minus m is substitute the p, and n you can substitute the p plus m. So z power minus m plus p. Okay, and separate these powers. Base is the same, and power we are already added. Now we can separate z power minus p and z power minus m. Take the z power minus m the outside and observe here the variable of p, it is equivalent of Z transform definition. So x of z, z power minus m x of z. The negative powers of z will get for the positive values of m. And similarly, you can take the Z transform of x of n plus m, x of n plus m. The sum of n is equal to minus infinite to infinite, x of n plus m z power minus n. Replace again the n plus m is equal to p here. N plus m is equal to p. N plus m, sorry. N plus m is equal to p. And n is equal to p minus m. And the limitations is also the same for n is equal to minus infinite. In fact, the p is also same. Replace the n plus m as a p and replace the n as a p minus m. Again, you can write the two parts here, the z power minus p and z power m. Take the z power m is outside. And observe here, the summation of p is equal to minus infinite to infinite. X of p z power minus p is similar to the term Z transformation definition with the variable of p. Z power m into x of z. Z power m into x of z. And now observe these two. For the positive values of m, there is a multiplication factor for x of z is z power minus m. For negative values of m, it is multiplied the z power, the positive powers of z to the x of z. And one-sided Z transformation. One-sided Z transformation. So what is a one-sided Z transformation? It's actually the Z power minus k x of z plus x of 0 minus x of 0 minus or x of n minus k. x of n minus k. Otherwise, the sum of I is equal to 1 to m, x of minus I, z power minus of m minus I period. Let take the z transformation of x of n minus m, z power minus m, x of z plus the another term we are added for the z power minus m x of z for the positive values of m and z power m x of z for the negative values of the m. Let you can see the proof also. For one-sided means unilateral z transformation. One-sided means unilateral z transformation. Now let us see the proof, my dear students, here. X of z is equal to z of x of n, the sum of I'm taking the 0 to infinite. So 0 to infinite means is a one-sided z transformation. Okay, one-sided z transformation. Take any graph here, the two-sided z transformation is from minus infinite to 0 and 0 to infinite, the two-sided z transformation. One-sided z transformation, one-sided 0 to infinite, and another side is also, we call it as a one-sided only, one-sided from minus infinite to 0. Now I'm taking the positive side here. The positive side is a 0 to infinite, x of n z power minus m. Okay. Substitute the x of n as x of n minus m and multiply z power m and z power minus m. So because the bases are the same, we can add the powers. Z power m minus m is a 0, z power 0 is a 1. So there is no any change in the above value, above equation, the below equation. Okay. So after that, we bring the z power minus m in the outside. The sum of n is equal to 0 to infinite. X of n minus m, z power, the two functions we have. That is a z power minus n and z power m. Take the z power minus as a common, n minus m will get n minus m. Okay, z power minus m sum of now we can see what are the limitations when we are changing the n values to the p values. Let n minus m is equal to p. I'm assuming the n minus m is equal to p. But what is the value of n is here? N is equal to 0. When n is equal to 0, the 0 minus m is equal to p. When n is equal to infinite, infinite minus m is equal to p. So the p value here minus m becomes, and the p value here the infinite. So change the p n values to the p values after substituting the n minus m as a p. So now the range is from minus m to the infinite. Minus m to the infinite, x of p, z power minus p. N minus m is nothing but is a p on. Got it, my students? Now, if I am changing the negative values from m to the infinite, inside there is a minus 1 and the 0 also. Take this 0 to infinite as a one term and minus m to minus 1 as a one term. Since it is a discrete, don't take the minus m to 0 and 0 to infinite. The continuous time function only, there is a minus infinite to 0 and 0 to infinite. Both one-sided will get the 0 value. But that 0 is not the 0 exactly. 0 minus is just below the 0 and 0 plus is just above the 0. In the continuous time function, it is okay. But coming to the discrete time function, it is a different. So minus m to minus 1, you can take one integral. Another integral is from the 0 to infinite. So I change the minus m to infinite as a 0 to infinite as a one term. Another term is minus m to minus 1. You see here, this is a minus m. P is equal to minus m to minus 1. So z power minus m, sum of p is equal to 0 to infinite x of p z power minus p. And in this second term, you see here z power minus p, both the values is a negative values only. Sum of p is equal to minus m to minus 1 x of p and z power minus p. So change this total, the summation, the negative values, and change the p values as a positive to the negative and negative to the positive. So that is becomes of the sum of p is equal to, I'm taking it as 1 to m positive values. Now change the p here, the minus p, and z power minus p already there, it is a p plus p. Got it, my dear students? Plus p. So you see the p is equal to 1 to m x of minus p and the z power p. So change it to both the negative values here, positive values, and change the p values of the negative in a summation, x of the function, the x of p and the z power minus p. Now I can rewrite the expression here, the z power minus m, sum of n is equal to 0 to infinite, x of p I am changing as a n because it's a variable only. P and the values you can change the n. So let p is equal to n in the first summation. So n is equal to 0 to infinite x of n z power minus n. And in the second summation, the p is equal to I. This is a I, my dear students. Don't think it is a 1. P is equal to I in the second summation. So z power minus m, but p is I'm changing as I is equal to 1 to m x of minus I z power I. Okay, z power I, this one. Now z power minus m, and you can write it as x of z power n is equal to 0 to infinite x of n z power minus m is a x of z, and this is not the z power plus m, my dear students, it is a minus z power minus m, and this is a definition of the unilateral z transformation, one-sided z transformation only, x of z plus sum of I is equal to 1 to m x of minus I, already minus I we have, and now I am writing these two as a single term, the z power minus m and z power I, z power minus of m minus I, z power minus of m minus I. Got it, my dear students? Okay. Now suppose if this function, if I am simply shifted one sample only, means nothing but m is equal to 1. M is equal to 1 means what is the function will get x of n minus 1. Since I am taking the m is equal to 1, one sample is shifted towards the right side. What is the z transformation for this? Z transformation x z power minus 1, here it is a minus 1, x of z plus sum of I is equal to 1 to m. M is nothing but here it is a value is 1 only. So means I is equal to 1. So x of minus 1 and z power minus of m is 1. And what is the I is also here it is a 1. 1 minus 1 is a 0. Z power 0 here. So that is the Z transformation is Z power minus 1 x of z plus 1 minus 1 is a 0. Anything power 0 is a 1. So x of minus 1. So this is a signal is added for the z power minus m x of z. The previously for the two-sided sequence. For the two-sided sequence, one sample is shifted towards the right side. The added signal is the x of minus 1. If two samples is shifted, so what happens? The two samples if shifted means m is equal to 2. If I am taking the m is equal to 2, what is the equation becomes? X of n minus 2 is a Z transformation. Is a Z transformation. Now I am taking the sum of Z power. See, my dear students, it's not the positive value, it's a negative value. Change is when I am shared the material to you. After listening only can understood where is something wrong is there. Okay. Z power minus m is nothing but now I will take the 2. Z power minus 2x of z plus, now what is the value of m? I is equal to 1 to 2. I is equal to 1 to 2. X of minus I and z power minus of m minus I. I expand this function. M is nothing but the 2 here. 2 minus I. The Z transformation is z power minus 2 x of z plus, when I is equal to 1, you can substitute x of I minus 1 z power minus of 2 minus 1. What is it? 2 minus 1 is nothing but 1 plus, and you can substitute the 2 also, x of minus 2 z power 2 minus 2. 2 minus 2 is a 0, z power 0 is a 1. So the two terms we can add when we can shift it two samples towards the right side in the unilateral Z transformation shifting property. This is the only property and difference for bidirectional Z transformation and the unilateral Z transformation. Still, we go for the increasing of m. We substitute the I is equal to 1, 2, 3. You get the 3 terms, my dear students. What is the last term? X of minus 3 on. And what is the before the term? X of minus 2 and x of minus 1. So on. Okay. It's a very, very important property. It is Z transformation. Now coming to the n plus m. N plus m. Sum of m is equal to 0 to infinite. Sum of n is equal to 0 to infinite. X of n plus m z power minus m. X of n plus m z power minus m is equal to 0 to infinite. X of n plus m. Here also what we did in the previous, multiplying the positive powers of z and the negative powers of z without changing the previous equation. So here also you can do the same thing. Z power m and z power minus m. Take the z power m as in the outside, because for negative values of m there is a positive powers of the z. Okay, got it, my students? So sum of n is equal to 0 to infinite. X of n plus m z power, the remaining the two terms we have here, z power minus m and the z power minus n. Take the minus as a common, n plus m. Now replace n plus m is equal to p. N plus m is equal to p. But here n is equal to, when n is equal to 0, when n is equal to 0, 0 plus m is equal to the p. Means the p is equal to m. So one limitation, when n is equal to 0. When n is equal to infinite, infinite plus m is equal to p. Infinite plus anything is infinite only. So p is equal to infinite. Now the range is varies from m to infinite. M to infinite. see here, m to infinite. But now if I'm taking that as m to infinite, the values 0 to 0 is there in the inside. The 0 is there in the inside. And now I'm taking the before value is m minus 1 also. M minus 1. So let us take here the m minus 1 from 0 to m minus 1. So 0 to m minus 1 and the 0 to infinite. Got it, my students? 0 to m minus 1 if I am taking one sample, and the 0 to infinite. So splitting of m to infinite as 0 to m minus 1 and the 0 to infinite. When 0 to infinite we can take it here. It's similar to that of unilateral Z transformation. Z power m and the x of z we can take. And another way here, the I is equal to 0 to m minus 1. Why I take here the 0 to? The previously we are not taking that from the 0 to infinite, that is a 1 to infinite only. But here the I is equal to 0. Since in one side the m minus 1 we got from 1 to infinite. The other way, the 0 to infinite or the 0 to m minus 1. If 1 to m, there is m number of samples. And 0 to m minus 1, that is also m number of samples only. Got it, my students? So I am taking the 0 to m minus 1, x of p, because m plus m is a p, and p is equal to m plus n plus m. So change is here also, whatever we did in the previous, the p is equal to n in the first summation, the p is equal to I in the second summation. First summation already we replace the p is equal to m and write the definition of the x of z. And in the second summation, the p is equal to I if I am taking, I is equal to 0 to m minus 1, x of p is x of I, and z power minus p is a z power minus I. Is also I minus 2, not is a 1. Now multiply the z power m to the z power minus I, it becomes of a z power m minus I. M minus I, x of I, z power m minus I. Previously you can see here, the positive, here there is a negative is there, x of I, now it becomes of positive. Here there is a negative powers of z, here now it is a positive value. Why? Definitely the power whatever we have in the first term is a z power m is becomes of a positive when we can take the negative values of m. So similarly, here also for the negative values of m, both the values is becomes of negative values as a positive. X of minus I is becomes here the x of I, and z power minus is becomes of z power plus of m minus I. Got it, my students? And the range is the same. I to m is number of m samples, and 0 to m minus 1 is the number of samples is a 1 only, not the 1. Number of samples is a m. Now let us take here also x of n plus m is a 1. 1. If I am taking the m is equal to 1, nothing but minus 1. So actually, minus of minus it becomes of 1 only. What is the Z transformation now? The Z transformation is the Z power m, nothing but is a 1, x of z plus, and sum of I is equal to 0 to, what is the m now? 1 minus m, 1 minus 1. 1 minus 1 is nothing but the 0 only, minus words. X of I and the z power m minus I. What is the m? M is nothing but 1, 1 minus I. 1 minus I. M is equal to 1, we already substituted here. So what is the Z transformation of that? Simplifying Z transformation, Z x of z plus, because of one sided, the another term is added for the z into x of z. I is equal to 0 to 0, 1. 0 to 0 means I is equal to 0 only have to substitute. X of 0, Z power 1. Z power 1. I is equal to 0 minus 20. Z power 1. Similarly, so X of 0 into Z is added to the Z into X of Z. Z into X of Z. Got it, my students? For positive values is a different and the negative values are different. For positive values of M, you get the X of minus 1, the initial conditions. X of minus 1 is the initial condition. Got it? And now, if it is a M is equal to 2, if I am taking M is equal to 2 in this function. So X of N plus 2, the transformation is Z power 2 X of Z plus sum of I is equal to 0 to, what is the M now? I am assuming the 2. 2 minus 1 X of I and Z power, and here the M is a 2. 2 minus I. 2 minus I. So expand this, the Z transformation now it becomes of Z transformation is Z square X of Z plus I to 2 minus 1 means the two terms will get the sum of I is equal to 0 to 2 minus 1 is a 1. Okay, so X of I Z power 2 minus I. Now you can expand this, not the expansion, expansion of the summation here. The sum of, not the sum of, the Z transformation is Z square X of Z. First I am taking the X of I is equal to 0 in this term. I is equal to 0 means X of 0 Z power 2 minus 0 means Z square. You see here, when I am taking the value is 1, X of 0 is multiplied with Z power 1. When I am taking the M is equal to 2, X of 0 is multiplied with the Z square plus another term will get. That term is I is equal to 1. So X of 1 Z power 2 minus 1. 2 minus 1 is a 1. So it is decreases when the function is decreases, the time is increases, the power is decreases. The similar fashion, the Z transformation of Z power 3 we can get here, 3x of Z plus x of 0, it becomes of Z cube plus, means it is a increases, the time is increases, x of 1, the power is decreases, Z square plus, and still if it is a 0, 1, so x of 0, when 1 is there, here you will get the x of 0, and the 2 is there, 0 and 1, the two terms, and then it is increases x of 2, x of 2, means the M is equal to 1, the last value is x of 0, signal. 2, the last value is a 1, x of 1. Now the 3, the last value is x of 2 with the power of 3, not the power of 3, power of 1. So see here, the time is increases 0, 1, the 2, and the power is decreases 3, 2, 1, and so on. Got it, my dear students? So two one-sided terms when n is minus 1 and m is equal to n minus m, and the transformation of n plus m. You have to remember this term is added to the z power m x of z, and the term is added z power m. So before that there is a minus, my dear student. It is not the plus. Minus is there. Minus term. Okay. I'm taking the minus of these values. Why this value is, it is a range of 0 to infinite. I am subtracting the values. Okay. Minus value. all these minus values, my dear students. These are not the plus, this is a minus, and here also the two terms is a minus and the two terms is a minus. See, there is a minus is there. Minus z power m and minus z power m and minus z power m minus I will get. Okay. This is a very important, my dear students. One of the property unilateral Z transformation, that is shifting property. Next, coming to the multiplication by n in the time domain, or the differentiation in Z domain. Differentiation in Z domain means it's a differentiation in the frequency. So when Z transformation of n into x of n is a minus z d by dz of x of z. Okay. Now what is the definition of Z transformation? The definition of the Z transformation is x of z is equal to integral, not the integral, it is a discrete quantity, students. X of z is equal to sum of n is equal to minus infinite to infinite x of n z power minus n. This is a definition actually. And what they are saying, the statement saying that the Z transformation of x of n is x of z, my dear students, not the x of the x of n. Let's rewrite this. After I shared this material, how to change, don't write directly the Z transformation of x of n as x of n. Some mistakes are there in the material, how to modify. And apply the derivative on both sides here with respect to the z, d by dz of x of z is equal to the sum of n is equal to minus infinite to infinite x of n. There is no any z term in this. So here only the z, so that function on both sides with respect to the z. So d by dz of x of z is equal to the sum of n is equal to minus infinite to infinite x of n. And what is the differentiation for the z power minus n minus 1. So x of n is n into n minus 1. Got it? So that is equal to, so rewrite this function, the minus is there, put minus in the outside, the sum of n is equal to minus infinite to infinite. Take n of n as a one single minus 1. This the sum of n is equal to minus infinite to infinite n into x of n into x of n z power minus n, and now I'm taking this 1 by z. So cross multiply the 1 by z and also put the negative sign to the left hand side, minus z into d by dz of x. The sum of n is equal to minus infinite to infinite n into x of n as a one function z power minus n. Now observe these two are not comparing these two equations. This is the definition of Z transformation and saying that x of n Z transformation x of z. These are the two weights. The time domain function when the signal is x of n, the frequency is nothing but z domain is x of z. What is a time domain function? This is the same definition, but the signal is n into x of n. So by multiplying the n into x of n, Think of the time domain function. What is the z transformation? The pair is instead of x of z here the minus z d by dz of x of z. Got it? The multiplication by n as a time domain, or it is also called as a differentiation in z domain. D by dz of x of z minus z into d by dz of x of z for the given signal n into x of n is a z transformation. What it matters, students? Differentiation property or the differentiation in z domain, or we can call it as a differentiation in frequency domain or multiplication by n for the time domain function. Got it, my dear students? So the transformation of n into x of n is a minus z d by dz of x of z. Okay, the remaining whatever the other properties we have, we can discuss in the another class. Okay, my dear students. Any doubts? Thank you.